All right, well, thank you so much for having us this morning. We are the Brighton team. This is Sam Hobbs, Jackie Torres, Mackenzie Gamage, and I'm Hannah Blue. We appreciate the opportunity to come before you today and really give you our insight and just our perspective on what would be best for orbital ATK in this scenario. Have you heard the tale of Melinda May? Tiny Melinda May. She ate a monstrous whale. She thought she could. She said she would. And she started in right at the tail. And everybody said, "You're just too small." But that didn't bother Melinda at all. She chewed really small, she chewed really slow, just like a good girl should. And in 89 years, she ate that whale, just like she said she would. Now, I know this isn't a poetry class, this is a supply chain case competition, but there is a reason. So what could this have to do with orbital ATK? And what it is orbital ATK has their own whale that they need to eat. And what that is how do we create a cost-effective transatlantic supply chain? Well, how are we going to tackle this large scenario that has tons of moving parts in an effective manner that's going to be useful in the long term and not just a short-term gain? And we're going to do it the same way that Melinda did, bite by bite. So I want to break down what specifically our whale is made of. So let's take a look. So the first piece of the whale is the coordination challenges. These are our underlying issues. And of course, this has to deal with transporting the parts from, currently they're going from Houston over to Tilburg, and then from there to the RSPs. There's lots of different moving parts with that, and we need to figure out the best way to manage those relationships. The next part is on-time delivery issues. We understand that in today's global world, everybody really needs to be focused on this, because if you won't deliver on time, somebody else will deliver on time. And this ties in directly to transportation modes, which are going to be our method of making sure that things are delivered on time. We need to find out what's going to be the best way to get things from point A to point B to make our customer happy. And then finally, the tail fin of the whale is delivery cost per unit. And this is essential because this particular piece is what will steer you either down into deep, treacherous water, if I could use more whale lingo, or into a safer area where you can conduct your business for a long time and really create a strong relationship with your partners. So I want to take a look at just the agenda and give you guys an idea of where we're going to go today. And so we're first going to take a look, just the context, and give you guys a brief overview of what we're looking at right off the bat. We're going to go into an analysis, and we're going to show you both a qualitative and a quantitative look at what we're going to be looking at as far as orbital ATK dealing with Airbus and how we can best assist them as they're being our customer. And then from there, we're going to look at solutions and recommendations, our perspective about what should go, what they can do to better help their business and to really serve their customer in the best manner. And finally, we'll recap and make sure we tie it all back together for you so we can really reinforce one last time the point that we're trying to get across. So the first thing that we really wanted to look at is the concept that Airbus, although presented throughout the time, it seems like they're partners, but in reality, they're our customer. And so we have to treat them that way. So as a customer, we realize that they follow the same customer value base that other customers follow. So we know that they focus on quality, cost, flexibility, delivery, and innovation. Gotcha. And so which one of these we had to decide would be most important for this particular issue? What could we focus on? Because we understand that we have to do it bite by bite. We can't tackle the whole thing at once. What parts can we look at that we can have control over to really make some influences and build a strong foundation for our solutions? And so what we decided was that we focus on cost and delivery, because we have high cost per unit and high delivery costs that we have to get down, and delivery, we got to get it on time. So these are almost tied together, and we know that we need to address both of these in order to go anywhere. So now that we understand our foundation, we wanted to take a look at how we could better serve Airbus. We were presented with Airbus's scorecard of orbital ATK, and from what we saw, it was very green. It looked good, and there's only one area, which is on-time delivery, that wasn't red, it was just a little bit yellow. And you could say, if you were another company, you might say, you know what, this looks pretty good. I'm sure many people Students like us see grades like that and we're like, this is fantastic. But has orbital ATK and understanding that Airbus is in an industry where Boeing is their top competitor, that if they give them an inch, they're going to take a mile. It's a race to market share. That's why it's very specific about how we can't decrease volume at all. We have to race to the market. We can't pause for even 1 second. So what we decided to do was use the Japanese method of Kaizen to really shape how we're moving forward. And we wanted to take on an attitude of continuous improvement.
All right, so the next scorecard you see here is actually one that we scored ourselves on. Now you may look at this and think that these scores are really low. Yes, they are very low, and that is because we are taking in the mentality that we need to be perfect. Our customer expects us to be perfect, and so that's what we need to maintain. We need to really maintain and take into consideration here. As you see, we took into consideration delivery and cost. Those are our main issues in relation to our issue at hand here. For delivery, we looked at and weighted heaviest timeliness. Of course, you want your product there on time. So we thought that that was the highest weight, and we gave ourselves an average score based on the information we got from the previous scorecard that you just saw. The other two that we looked at for in regards to delivery are lead time and our forecasting. Currently, we really don't have this in place, and that is why you see such low scores here. Next, we're looking at cost. So the highest weight here is the defects. We have an incredible amount of defects, and this is due to the product that we're using. It's a mystery, and we're having to deal with that and constantly change and adapt to that mystery. We're doing pretty well here, and so, but we still have those defects, and that's still something we got to work on. So that's why we have such a low score here. Our defects are at 8%. So now we have our costs per unit as well as our transportation mode. These are tying together here in this point. Our transportation mode is very effective, it's fast, however our cost is incredibly high. So that's why you see the changing scores of the low cost per unit and the high transportation mode scores here. So moving on, we looked at orbital ATK and this case with a gap analysis. So what we need to consider here is where we want to be in the future. And that's really what this whole entire case was looking at. Where do we want to be in the future with Airbus? And we also looked at where we currently stand and how are we going to get from where we are to where we want to be. In the future, we want to really drive that delivery cost per unit down and below the target. As well as we want to implement a cost-effective supply chain from our inbound going towards our 3PL. By doing both of these, it'll allow us to get that on-time delivery of 100%. We don't even want to maintain it here. At this point, we want to focus on the future of being at 100%, being perfect for those customers. Currently, we are at an 8% defective rate for the amount of products that we are producing. We are looking at decreasing this 8% to 4% in the short term, and eventually to 2%. However, this 8% is where we do stand as of today. Our transporting is via truck as well as via air. As I mentioned before, air is incredibly expensive. Truck is our only option. We won't sway away from that. Our on-time delivery is not 100%. As you saw in our customers' analysis of us, we're not hitting what they expect. And our final point here for where we currently stand is the fact that our delivery cost per unit in 2015, the average each month was over 60% of our target. We do not want that. We want to be at below our target. So this is probably the key and the worst thing that we have going on right now for us. So how are we going to get from where we currently stand to where we want to go? We're going to bridge that gap by implementing ocean freight. By implementing ocean freight, this will allow us to drive those costs down, as well as we'll be able to increase our on-time delivery. We really want to focus on meeting those coordination issues that we have right now with our lead time and our forecasting. Once we are able to create a more transparent supply chain, going upstream and downstream, this will really allow us to also hit our on-time delivery, as well as hit that, make sure we have just that coordination that Boeing didn't have when they dealt with this. So looking at the strengths, weaknesses, opportunities, and threats that Orbital has currently. Our number one strength here is our innovation. We created the AFS system, and that has allowed us to increase our quality, decrease our cost, and move at a 10 times faster pace. We've also been able to earn incredible certifications, and this is why Airbus chose us. We have these strengths, we are number one. Our weaknesses are, like I mentioned before, our quality is, we're having 8% defects currently. We also are dealing with a difficult product. We have some products that are up to 17 meters in length. Our typical FEU is about 12 meters in length. Can't just snap it in half. So we really have a hard time dealing with that and the shipping crate sizes. So another weakness is our production scheduling. Our forecasting isn't there, and we don't have the collaboration and communication that we need. Our opportunities, in 2015, there was 1 month that we were able to hit below our target. We know it's feasible, we know we can do it. So that's where our number one opportunity lies here. We also have the ability to transport via ocean. We don't have any contracts or constraints with who we're transporting our product through. Now for our threats, they all kind of tie together. Our on-time delivery is eventually, as Hayden had mentioned, they will go somewhere else if we cannot meet their expectations. This brings us to our delivery cost per unit. If we don't drive these delivery costs down, we do not have a sustainable supply chain. We won't make it in the long run. We won't be able to complete this contract. As well as our customers are located in Europe. We can't easily communicate our products from Clearfield, Utah to Europe in 24 hours, which brings us to our spares. If something breaks in Europe, we're screwed. We can't get it from Clearfield to Europe in 24 hours. And so this is where the 3PL comes in, which is great. However, we do have the issue of getting it there on time still.
So, Mackenzie and Hayden have drawn up a really great picture about what kind of well we are currently chewing on. Like Melinda May, we had a big issue at hand. Also, Boeing, something to note, was in this industry with the carbon fiber airplanes. 7 years they entered the market before ATK or before Airbus did. Now, their whale that they were chewing on was equally as large, if not larger. And this caused implications that set them back 3.5 years to make the market to share, or the market share that we have gained just a 3-year gap between the two, between Airbus and Boeing. So we've noticed that we have a few conditions with ATK, with Airbus, and all of these different implications and constraints cause us to have to create assumptions when we make an analysis and present a solution to help the advisory board and the board of directors make their final decision. So one of the assumptions that we have to make is that these 5 RSPs who are located in Europe in different regions are on an inconsistent schedule of production. Though they may operate under the name of Airbus, they are operating different manufacturing processes and at different rates and different efficiencies. This causes a hassle for our 3PL that's located in Tilburg, who has to accommodate to their needs, who eventually, like the bullwhip effect, connects back to us as the supplier, the manufacturer of the parts that we're producing for them. So, of all these implications, it's probably the most notable that they are operating a lean manufacturing center. They don't hold any inventory, and if they do, it's spare inventory, saved, reserved inventory. So, when it comes down to it, we kind of created this little teaser chart to kind of give you a little visual of what we have projected the cost. We have currently only created 15 airplanes that we are contracted of the 805. That leaves 790 left to fulfill the contract that we have with Airbus. This implies that we have many parts still on the table that have to make it out of our shop. So at 684, we have over, as we see, where's that button? We have over 540,000 parts that we need to make to fulfill this contract. We know that there will be some defects, so we're going to shoot for that. As of right now, we chose to just stick with the same rate that we have to keep things constant at that 8% rate. And with creating this new idea that we have as far as with the logistics system, we are estimating to cut nearly $15 million during the course of this contract to be able to come out saving some money. So in order to do this, we have to create transparency along the supply chain. It's a must. We currently have a system of SaaS, service as is, service software that creates this transparency that we can see from the end customer, who is our RSPs, well, the most important RSPs that we currently have, all the way up to us and through our 3PL facility in Tillman's. So we have to know what efficiencies and what rates these facilities are producing in our RSPs so that we can adequately supply our 3PL. Along with that, we have to understand basically a fundamental principle that we've learned from our buddy George Santayana, that if we don't learn from the past, we will be condemned to repeat the same mistakes. We noticed this from Boeing, that they ran into inefficiencies with their processes and with their logistics also. So we're going to use an intermodal design. We are going to use a combination of both air freight and shipping across the ocean via our cargoes, or our ships. So with this, we decided that we are going to stray away from the idea of using reusable containers. We looked into this, and there's many complications that could arise that potentially would increase our costs higher than what we would have profited from ever in beginning this endeavor. This cost is about $1 million or so, and we feel that it's not as wise to go that route due to the complications with the timing of how long it will take to get there, with how long it has to sit at the 3PL for the 2 weeks, to the point where the most economically way that we could do it is to wait till all 4 containers are ready to ship back. This is basically setting us up to have to wait for 14 weeks from the time we leave it, or that we send it off to our 3PL across the ocean to bring it back to the US and back to ATK to reuse it.
So let's dive a little deeper into our transportation modes. For our air shipment, we have a few different options. Each option consists of a variety of containers ranging in length from 20 feet to 55. The cost per container mix would be as low as $10,000 and to just above $11,000. The base cost is related to the longest container in our mix. So by adding these together, it would appear that option D would be the one to go with. However, this option would not provide us with the 55-foot container needed in order to ship our longest products. So we suggest to go with option C. Option C has the single 55-foot container that we need to ship those long products. It also has a variety of containers that are suitable for the rest of our shorter products. So now moving on to the ocean shipments. For these shipments, we suggest using the non-reusable containers. The reusable containers are much more expensive than the non-reusable ones. We'd also have to wait a great amount of time before we even get these back so that we can reuse them. So this makes the reusable containers not only extremely cost inefficient, but time inefficient as well. So by implementing our recommendations, Well, I'm sorry, let me back up a little. We know our biggest issues are cost and delivery. So by implementing our recommendations, we would be able to conquer these issues. With our current supply chain, there's no way that we would be cost effective. There's also no way that we would survive in the long run. So with our recommendations, we're going to see a more predictable demand schedule. This would be a direct causation from our increased transparency. Together, these are going to greatly decrease our shipping costs. So our delivery costs per units are going to decrease as well. This would be due to the two different modes of transportation that we're using, air and sea. The modes of transportation would also relieve our issues that we're seeing for the on-time delivery. So in the long run, we're going to see a much stronger coordination throughout our entire supply chain. Thank you for your time. We're now open to any questions you may have.
So we have a 15-minute question and answer period.
Hi, were you able to determine how much percent, what percent would equal the expected costs? So you have a defective product, you have 8%, I believe. What does that equate if you were to bring it down to 7% as far as savings and how that improves supply chain?
That's a very good question. I'm not entirely for sure that we were provided information of the cost per unit that was given into the equation that would allow us to calculate the cost savings for manufacturing.
But if I may, we did make some assumptions and we looked at different effects that it would have on our transportation, and lowering those defects actually was making it so we could get things out the door quicker, because we have products that we're making and then they're defective, we have to make another one to ship it out. So we understood that it would start saving us some time. So we did know that if we can decrease it, it's definitely going to be beneficial, and we need to do everything we can to diminish that.
It is a very visible complication that's going on because a company like ATK, who is a leader in engineering and manufacturing, who is used to having extremely high efficiencies with their production line, is now going from what a Six Sigma standard is of 3.4 parts per million to roughly 800 parts per million. And so that is something that does need to be looked into to help out everything.
Good answer, thank you.
You look at sustainability with the reusable container. Most companies already do fairly. You look at what it would cost to build a better reusable container that could have, shortened that time when it was out of service at 14 weeks.
The problem is where we don't currently have the reusable containers, we're basically going to start using one per week with our loads that we're sending out. So we're going to have to be purchasing one per week, basically, until we can get the first one that we sent out back home. But that's not just the 26 days that it takes to arrive to Tilburg. It's an additional 2 weeks that it has to sit in their warehouse, plus a couple extra weeks to allow that there's 3 more containers, so we can send 4 back to us. Because otherwise, if you were going to be spending for one empty container to make it back all the way to ATK, your costs are going to go through the roof. That's not economically thoughtful at all.
Did you look at how many containers you would need if you be able to do that? If you did go to reusable, how many containers would you need?
Yes. So if we were to go to that route, it would take 16 just to get us started. And that's assuming that our demand is current where it's at, where our target goal is at 8 shipments per month, where we're splitting it, but one shipment's going to be air freight, and the other shipment's going to be through the cargo tank. So when we do it that way, obviously those are constraints, those are assumptions, but it would take 16 to start it off, to get it going. Once the demand increases, and we get our forecasting down as far as the parts we're sending in those ship tanks versus the ones that we're sending in air freight, we would have to increase our quantities.
I was going to say, time that it would take to ship the container back? Is that part of the 14 weeks? That's the other part, right? You said it was going to be out of service for 14 weeks. That include the return time also? Or?
Exactly. And you have the upfront cost of $52,000 per cargo container. So you have 52 grand that you're putting into one of those. Now you have an additional $6,500 to send it over to that 3PL. And then you wait for 3 more so that you can have a batch of 4 to spend $6,500 again to bring those 4 back to ATK.
You have a chart there that had, the numbers on there, the cost. Can we go back to those numbers again? Go back to the one with the main assumptions. You have the 8% of the defects stack. How did you get to your total shipments, the 587?
Okay, so the total shipments, we had an average per week, came out to be, we were able to ship about 1,000 parts per week. So taking into consideration the total of parts that we would have to be making and 1,000 parts per week, we're looking at 587 shipments from the current, where we've only made 15, to the end of our contract that we have created with Airbus, which is 805 planes. So the 587 shipments is what it will take to get all of the parts for all 790 planes from Clearfield and to the Netherlands.
You go back to your other cost table and put some of the container costs in it. So the total cost that you have in there, is that the life of the program? Or is that like per
There is no
shipment?
total cost, it's actually highlighted in there, combining the program.
This is the total cost would be the container mix cost plus the base cost. So it's just I believe the containers were, some of them were like 4 of the largest containers, others were only just 1, and a few of a mix of the smaller ones.
So this would be a per shipment cost here for the 587 shipments.
Yes, that's right.
Well, when you look at the highlighted C, that 40,000 plus the green cell, that's 13,000. And that takes us back to the previous cost slide.
I'm just curious, the cost, like over the life of all these shipments, the cost of all the returnable, is that more or less than the cost of having the upfront cost of a returnable?
Calculating it out with the quantity that we have to deliver with this current contract, the upfront costs do outweigh the non-reusable container. Does that answer your question?
Yeah, that's what I was wondering.
Is there salvage value in the used container?
There possibly could be. How much of the salvage value is in your car after you buy it?
That's what I think. Especially, sustainability is going to be a huge part of this.
Oh, yes,
Because
it is.
that's going to be a lot of containers that you're having manufactured, so.
If you as a group took that picture of the well diagram, what do you think you could have the most impact as a supply chain team? I mean, obviously you have planning involved, you've got forecasting involved, you've got costs, transportation costs are all one time. We haven't seen this in decades. So where do you see your biggest contribution is?
I think the biggest place that we could have an effect is in the coordination challenges, specifically because that focuses on a lot of the intangibles and establishing those relationships that can last through the ups and downs in the market so that when things get bad, we can still maintain those relationships with the RSPs or with Tilburg so that we can let them know when things are going bad. Because if things do have hiccups or things do get suddenly expensive, if we have a solid relationship, things will still be able to function.
And unfortunately, if you don't have that foundation of coordination and a choreographed system, you're not gonna get the remainder of those.
Good answer. Good point. So you're looking at it more strategically, than anything else.
As a
Some of this
foundation.
is tactical, but you're right there. That's
Well, it's the brain of the well.
good answer.
We also took into consideration, one of the last pages of our case said that we have already invested or attempted to invest in reusable containers, but we were unsuccessful in getting Airbus onto that idea. So ultimately, if we are able to increase the coordination challenges and the reusable does end up being the best choice, we will have better horsepower with them ultimately.
And we did consider the effect that it would have on the environment, because we know that it's not just about what the money is going to be in the short run. As we considered the triple bottom line and just the effect that it would have on society. We understand both sides that it's better for everybody to be healthier, to have less pollution in the world, and it's better to have that reputation that's bought from doing things that are green and things that are renewable. But it was actually, we would have to ship more things by using those, and it was going to counterbalance it and actually cause us to pollute more from what we looked at.
So if we were provided more proprietary information, we could tell you a bigger impact that maybe going to those containers would be. However, given just the constraints of this particular case, it doesn't outweigh the benefits.
So I'm gonna ask an open-ended question here. The current model that Orbital ATK has right now, going through Houston over to Tilburg, then out to the RSPs, did you guys look at that whole process as a whole and consider different ways of going about delivering parts to the RSPs? Bypassing Tilburg, is there something else out there?
It would consist of basically finding another 3PL. And where we put in a bid for 12 3PLs until the one in Tilburg came out to be the top scoring, and we chose it as far as ATK making that decision. We were confident in their decision with finding the best 3PL provider.
We also considered where Boeing slacked in this department. They as well had gone global with their suppliers, and their costs skyrocketed and their delivery times ultimately failed them. And so we feel that our 3PL is really what's going to help us get through that hard time that Boeing experienced and make sure we didn't see that.
In addition, Orbital ATK they are aware that they aren't an expert in logistics, so that is why we chose to stay with the 3PL.
Is there any savings if you were to take your lighter weight products and utilize both ocean and air combination to meet at the same time when you get to Tilburg, use them more as a consolidator? But right now it's shipped as an entire kit. So it's shipped as an entire kit now. Sometimes those parts are held up here for one part or two parts or whatever. Would there be at advantage to go ahead and ship those parts out with an air freight follow-up of some sort? Or that may have been the next step in this whole process.
We actually considered that about roughly 4 a.m. last night. We brought up the concept.
This is a little out there, because she mentioned the 24-hour, the recovery, it's pretty difficult. Go ahead, I'm sorry.
Well, no, it's fine. We had this idea. What if we were able to use Tilburg as a sort of cross-dock temporary storage place where we could ship consistently to Tilburg, lowering our delivery costs by being able to ship things constantly and steadily there. And then, of course, that would have to deal with the transparency with the RSP, so we know what was going on there. And then what we could do is the RSPs could just take it from there, and we could monitor what was being used all throughout the Tilburg warehouse, and then we could just continue to keep that stock. And as we get better predictively forecasting things and get more data on the situation, we can create a scenario where we're not trying to rush, and we can get away from the if it's finished, ship it. Because we realize it's pretty fast. It's pretty fantastic that they're able to do that. It is a fascinating feat, but it's not something that can last in the long term. And we did actually consider different sayings of what we could do, and there were different things that came up, like choose the right stream and they were all whale related, but it was around that.
And in fact, with given from the plant tour that we went on and the case that we were provided with, we were informed that we're not necessarily sending complete kits from ATK to Tilburg. We're just sending what we can send them, basically, that comes off the manufacturing line. And so what we do know is that given the data in our workbook, we have 57% of our parts are particularly the Omega stringer, which is under the requirements to be able to fit on our Freightliner. So if more than half of your parts are under the big category of the Omega stringer, you can basically safely assume that these RSPs need a higher quantity of that part than any of the others. And if we could start shipping those ones through the boat and through our cargo, then we could possibly, then do the predictive analysis and the strategic kind of plan to forecast with that boat. So.
Okay, thank you so much.